Hello students, and again I'm your instructor, Sir J. Robert Erlaceda, and for today our lesson is about the Gay-Lussac's Law. Okay, so here we have Gay-Lussac's Law. Sulat ko lang po. Gay-Lussac's Law. So take note that your Gay-Lussac's Law is your temperature-pressure relationship. So this is your temperature-pressure relationship. Temperature, pressure, relationship. And according to this law, at a constant volume and amount of gas, your temperature daw po is directly proportional to pressure. So here, I will write the statement of this law. Okay, siguro violet na lang. Here, according to this law, at constant volume, at constant volume and amount of gas, so your temperature is directly proportional to pressure. Here, your temperature is directly proportional to pressure. Okay, so it means here I will highlight this. I will put an underline here. Let's underline temperature and pressure. So again, according to this Gay-Lussac's law, or the temperature-pressure relationship, you have the direct relationship between your temperature and pressure. So again, anong ibig sabihin ng direct relationship? Here, so ibig sabihin po ng direct relationship, if we increase, okay, let's use blue. If we increase, for example, the temperature, so if we increase the temperature, you have faster moving particles, tama? Kasi meron silang tumataas ang kanilang average kinetic energy. So if you increase, for example, the temperature at meron kang faster moving particles, ang mangyayari po is tataas din ang pressure. Okay? And if, for example, you decrease the temperature, magde-decrease din po ang ating pressure. They are directly related. Okay? It means if we increase again yung isa sa ating factor, if we increase yung isa, this temperature, tataas din po ang pressure. And if we decrease our temperature, magde-decrease din po ang ating pressure. Again, pag tumaas yung isa, tataas din yung isa. Pag bumaba yung isa, bababa din yung isa. So, it means they are directly related or directly proportional. And this Gay-Lussac's law po ay may factor na kino-consider, and that is constant volume. So, sa definition or sa statement ng Gay-Lussac's law, ang dapat ninyong tandaan ay meron kang constant volume or hindi nagbabagong size na container. It means hindi siya nag-expand. Okay? And kung meron kang container na hindi nagbabago in size and nag-supply ka ng heat, tumaas ang temperature, nag-move ng mabilis yung mga particles, ang mangyayari kung hindi magbabago yung volume ay mas mataas yung chance na ma-heat nitong mga particles na to yung walls ng container. Okay? And kung na-heat nila yung walls ng container, tataas yung pressure kasi hindi nagbabago yung space na in-occupy nila. Okay? Habang gumagalaw sila. Yun po. Yun po ang ibig sabihin ng Gay-Lussac's law. Okay? Sige, i-demonstrate ko to gamit itong illustration. So let's have here, for example, this is an atom. Wag na atom, molecules na lang. Kasi marami sa gas naman ay molecules. So, for example, you have here gas molecules. Then, let's consider this as a container. Here. So, according to Gay-Lussac's law, we have a constant volume or meron kang container na hindi nagbabago. Okay? Hindi nag-expand, hindi din nagko-contract. Fixed lang yung space na ino-occupy ng iyong gas particles. Or dun sa container natin, hindi siya nag-expand yung container. So, if meron kang ganon na condition, constant yung volume or hindi nagbabago itong size ng container, hindi nag-expand yung container, anong mangyayari if we increase the temperature? take note that if we increase the temperature, nagkakaroon din ng increase sa average kinetic energy. Ibig sabihin, your molecules po, your gas molecules, they move faster, okay, hanggang ma-hit nila yung isa't isa. So, nagkakaroon ng collision between molecules and with the walls of the wall of the container. So, dito yung ating molecules, nagkakabanggaan sila dito na nasa container, and with that, may tendency din nilang ma-hit yung container, itong walls ng container. At anong mangyayari kapag na-hit nila yung walls ng container? Kung mabilis ang galaw nila at hindi nagbabago ang space nila, tataas ang pressure sa loob kasi hindi nag-expand yung container. Ibig sabihin, gumagalaw sila ng mabilis sa space na hindi nagbabago. Okay? Dahil constant yung volume. And with that, tumataas ang chance nilang ma-hit yung container, lumalakas sila ng lumalakas ng galaw or bumibilis ng galaw. Ang tendency, tataas yung pressure sa loob. Okay? And yun po yung tinutukoy ng ating Gay-Lussac's Law. And pwede din natin consider what if, for example, mababa ang temperature. If mababa yung temperature, meron kang mga molecules na mabagal ang galaw. And kung mabagal ang galaw nila, lesser yung chance nila na mag-collide with each other and with the walls of the container. Okay? So with that, mababang temperature, ibig sabihin, mababa din ang pressure kasi lesser din yung chance na ma-hit nila yung isa't isa and yung walls ng container. Pero kung mataas naman ang temperature, mataas ang kinetic energy, ibig sabihin, mas mabilis silang gumagalaw, mas mataas ang chance nilang ma-hit yung walls ng container. And dahil hindi nagbabago yung volume, again, you have here your constant volume, ang tendency, dahil hindi nagbabago yung volume, is mabibuild. Magkakaroon ng build-up ng pressure sa loob. Tataas ang pressure. If you have, for example, a high temperature. Okay? So, yun po ang Gay-Lussac's Law. Again, your Gay-Lussac's Law is your temperature-pressure relationship, and according, or the statement of this law here, at constant volume and amount of gas, your temperature is directly proportional to pressure. Okay, now that you're already familiar with the statement of the Gay-Lussac's Law, let's consider now the formula derivation. Okay. Here, dun tayo mag-formula derivation. Formula derivation. Okay, so for the Gay-Lussac's Law, we have a main formula for this. For the Gay-Lussac's Law, the main formula is P1 over T1, or T sub 1, equals P sub 2 over T sub 2, or you have P1 over T1 is equal to P2 over T2. Take note, ito yung main formula ng ating Gay-Lussac's Law. The main formula of your Gay-Lussac's Law. And with this main formula, we can derive other formula. So, pwede natin kunin yung formula for P sub 1, T sub 1, P sub 2, and T sub 2. Okay? Let's begin with the P sub 1, or your initial pressure. So, bago pala ako mag-start, here, your P sub 1 here is the initial pressure, then your T sub 1 here is your initial temperature, then your P sub 2 here is your final pressure, P2 or P sub 2 po, that is the final temperature. Final pressure. Sorry. Muntik na yun. Here, this is your final pressure. Then, this T sub 2, ito naman po ang ating final temperature. Again, your P sub 1 is your initial pressure, your T sub 1 is your initial temperature. Your P sub 2 is your final pressure, and your T sub 2 is your final temperature. Okay, let's derive the formula. Okay, let's get the formula for P sub 1, or initial pressure. Okay, hanap tayo. So, formula for P sub 1. Okay. Then, para makuha mo yan, dapat alam mo lagi yung main formula. So, the main formula is P sub 1 over T sub 1 is equal to P sub 2 over T sub 2. Okay? So step 1, write the formula, the main formula. Step 2 is cross multiplication. So here you have your P1 over T1 is equal to P2 over T2, then cross multiplication. Ibig sabihin, this T sub 2 mamamultiply with our P1, and this T1 mamamultiply sa ating P2. Again, your T2 mamamultiply, okay, para di kayo malito, ibahin natin ang color. So here, your T2 or T sub 2 mamamultiply sa yung P sub 1 dahil cross multiplication, then this T1 mamamultiply sa P sub 2. Okay? And with that, magkakaroon tayo ng product nito. Meron tayong P1 T2 is equal to, so P1 times T2, yun po ay P1 T2, then T1 times P2, you have your P2 T1. Okay? Then, with this, hanapin natin yung formula ng P sub 1. Okay? Gamitin po natin red color for P sub 1. Again, your target is P sub 1. I-write ko lang ulit siya. So, here, P sub 1, T2 is P sub 1, P sub 1, T sub 2 or T2 is equal to P2 T1. Okay? Then, for this, step 3 tayo. Okay, wag yan. Violet na. Okay, so here's step 3. Step 3 po is tingnan yung katabi ng hinahanap. Okay, so your P sub 1, which is our target, ay next to your T sub 2. So kung sino yung katabi ng hinahanap mo, so ang katabi ng hinahanap natin here is yung ating T2. So P1 ang hinahanap mo, ang katabi niya is T2. So ipandi-divide natin yung katabi niya sa both sides. So dahil T2 ang katabi ng target ko, ipandi-divide ko yun both sides. For you to cancel this portion here, and now you're left with P1 on one side, and sa other side, wala ka nang makakancel. Tama? So here we have P sub 1 is equal to, here we have P2 T1 over T2. So, ito na po ang ating formula for P sub 1. Again, your formula for P sub 1 is P2 T1 over T2. Okay, P2 T1 over T2. Next, let's consider naman po, add lang tayo ng slide. Let's consider naman po ang ating initial temperature. So, let's consider initial temperature or T sub 1. Okay, so for T sub 1 or initial temperature, here, rewrite mo muna yung main formula again. P1 over T1 is equal to P2 over T2. Then, second step is cross multiplication. So here, P1 over T1 is equal to P2 over T2. Then, cross multiplication. Here, then here. So, meron tayong P1 T2 is equal to P2 T1. Okay? Then, after that, baguhin natin ang color yung ating target. Your target is T sub 1. Okay, so, check mo yung katabi ng hinahanap mo. Ang katabi ng hinahanap mo, your T1 is next to your P sub 2. So, gagamitin po natin yung katabi ng ating hinahanap. So, dahil ang hinahanap mo ay T1, katabi niya ay P2, gagamitin mo yung katabi ng hinahanap mo na pan-divide both sides. Lagi pong ganon. Okay? Para maiwan na lang sa isang side yung target. So, here, cancel natin. Dahil parehas na P2, cancel. Here, wala nang magkaparehas. Meron kang magkakaiba. You have here P1, T2, and P2. So, dahil wala nang magkakapares dyan sa side, wala nang makakancel dyan. So, here, now your formula for T sub 1 is P1 T2 over P2. Okay, so ito na ang ating formula for T sub 1. Okay, now let's consider the formula for P sub 2. P sub 2, formula for P sub 2. Again, rewrite lang yung ating main formula. Main formula is P1 over T1 is equal to P2 over T2. Then, second step is cross multiplication. Okay, rewrite again. T1 is equal to P2 T2, then cross multiplication. Here, then here. Then after that, magkakaroon tayo ng P1 T2 is equal to P2 T1. And again, yung target natin is your P2 and your P2 is next to your T1. So, gagamitin natin yung T1 na pan-divide sa both sides. So, here, your target is your P2 or your final pressure. So, ang katabi niya po is yung ating T sub 1. So, let's use that T sub 1 para pan-divide both sides. And now, we can cancel this T1 dahil sila ay parehas na T sub 1. And now, you are left with P2. On this side, you have P sub 2 is equal to your P1 T2 over T1. Okay, so this is now your formula for P sub 2. Okay, last one is your formula for T sub 2 or final temperature. So here, let's write T sub 2 or final temperature. Again, write the main formula. The main formula for Lussac'S law is P1 over T1 is equal to P2 over T2. The next step is cross multiplication. Again, rewrite P1 over T1 is equal to P2 over T2. Then cross multiplication. Here, P1 T2 and P2 T1. So here, after cross multiplication, kakaroon tayo ng P1 T2 is equal to P2 T1. And again, your target, your goal is to locate the form or to get the formula for your T sub 2. So let's highlight. So your target is this T sub 2. Okay? Medyo pumangit. Erase natin. So again, your target is this T sub 2. And your T sub 2 is next to your P sub 1. So gagamitin natin yung P sub 1 pan-divide both sides. Okay? Laging titingnan yung katabi ng hinahanap. Kung sino yung katabi ng hinahanap mo, ipan-divide mo in both sides. Para maiwan yung target sa isang side. Okay? And sa other side, wala nang makakancel. Okay? Here, para makancel itong P sub 1, at may iwan na yung target mo sa isang side. Now, you are left with T sub 2. And yung formula natin sa other side, we have your P2 T1 over P1. And now, complete na ang ating formulas. Balik lang tayo here from, again, for your initial pressure, your formula is, here we have P2 T1 over T2. Okay, and for your T1, the formula is P1 T2 over P2. And for your P2, the formula is P1 T2 over T1. And for your T sub 2 or T2, your formula is P2 T1 over P1. Ngayon, complete na ang ating formulas. Okay, so now let's consider sample problem for this Lussac'S law. Okay, so let's start here. Problem number 1. A gas has a pressure of 3 atmosphere or ATM at 127 degrees Celsius. What is its pressure at 227 degrees Celsius, assuming that the volume remains constant? Okay, so let's begin first with our given solution. So here first, the given is, first for your pressure, the given for pressure, your P1 is equal to 3 atmosphere or ATM. Then the given for your initial temperature, so here Again, from your problem, a gas has a pressure of 3 atmosphere. So, meron kang initial gas daw, then ang pressure po nun is 3 atmosphere at 127 degrees Celsius. So, ibig sabihin, yung gas mo na yon, ang initial temperature niya po ay at 127 degrees Celsius. So, here we have 127 degrees Celsius. And then, what is its pressure at 227 degrees Celsius? Ngayon, ano daw po yung magiging pressure niya at 227 degrees Celsius? So, this 227 degrees Celsius is your final temperature. Okay, so ano yung magiging pressure niya daw sa temperature na yan? So, here, black pa lang gamit. So, here we have T sub 2 or temperature 2. You have your 227 degrees Celsius. And the question again is, what is its pressure at 227 degrees Celsius? So our goal is to determine. Okay, our goal is to determine the P sub 2 or final pressure at this temperature at 227 degrees Celsius. So hinahanap natin is P2, assuming that the volume remains constant. So this is a Gay-Lussac's law problem. So let's solve. So, bago ka mag-solve, take note na you need to convert this temperature unit sa Kelvin unit. Okay, so here we have degree Celsius unit. We need to convert this sa Kelvin bago tayo makaproceed with the calculation. So, halos katulad ito ng ating Charles' law. Ang pinagkaiba lang, ang constant mo sa Gay-Lussac's law ay volume. Okay? Then here, convert muna natin siya again for the formula. Ang formula ng conversion for Celsius to Kelvin, again, your Kelvin is equal to degree C plus 273.15. So, for the T1, kung i-consider mo ang 127 for T1, so this is 127 plus 273.15. Then, solve muna natin siya with our calculator. 127 plus 273.15. Check ko lang, baka nandidilim ang mata ko sa ngayong gabi. So here we have 400.15 degrees Celsius. No, not degrees Celsius, Kelvin. Okay, again, this is Kelvin kasi formula na yun ng Kelvin. Okay, then another temperature. So to convert this 227 degrees Celsius into Kelvin, we need to use this formula, degree C plus 273.15. And your value for degree Celsius from the given is 227 plus 273.15. So 227 plus 273.15, this is equal to 500.15 Kelvin. So this is 500.15 Kelvin. So ayan, meron na po tayo. So ngayon, change lang natin itong 127 degrees Celsius. So now your 127 degrees Celsius, siya na po ay C 400 para di ka malito. So kinonvert na natin itong 127 degrees Celsius into Kelvin. So this 127 degrees Celsius is now 400.15 Kelvin. Then this 227 degrees Celsius is now 500.15 Kelvin. And with this conversion sa Kelvin, we can now proceed sa ating calculation. So let's solve for this. So ang goal natin is kunin yung formula for P sub 2. So your main formula again is P1 over T1 is equal to P2 over T2. Then cross multiplication, we have P1 T2 is equal to P2 T1. Then after that, check mo yung target. Your target again is your P sub 2. So your target is this P sub 2. Tingnan yung katabi ng target. Ang katabi ay T1. Okay, your P2 is next to your T1. So gamitin yan, pan-divide both sides. Cancel this area dahil parehas na T sub 1. And now you're left with P2. So formula for P2. P2 is equal to, here we have P1 T2 over T1. Okay. Now, let's substitute. So, P1, we have a value for P1 is 3 atmosphere. Then, your value for T sub 2, your T sub 2 is 500.15 Kelvin. Take note, lagi pong ipakita ang cancellation. Kasi pag hindi nyo pinapakita ang cancellation, ibig sabihin, mali yung unit na binibigay ninyo. Kasi, mamaya, papakita ko sa inyo ha. So, here, T sub 1. For T sub 1, your given is 400.15 Kelvin. Okay. Kapag kinuha nyo po ang final answer and di kayo nagpakita ng cancellation, for example, hindi ko pinakita ang cancellation, ibig sabihin, kung hindi ko siya ipapakita, ang unit na matitira sa'yo is yung value ng P sub 2, then ang unit na matitira sa'yo is ATM times Kelvin over K. So, yun yung may iwan sa'yo na unit. Okay? Kasi hindi mo pinakita yung cancellation. Take note in performing gas law problems and any math problems po, kailangan pinapakita ang cancellation. Kasi with cancellation, nalalaman natin ano na lang yung naiwan sa'yo. So, because we have same Kelvin temperature unit here, kakancel mo siya dahil same sila. And now you're left with atmosphere unit. Okay? So, yung atmosphere ba ay unit ng pressure? Yes po. So, ibig sabihin, tama ang naiwang unit sa atin. Okay? Laging cancelin kapag magkaparehas. And laging ipakita ang cancellation. Here, 3 times 500.15 over or divided by 400.15. This is equal to 3.749 or 3.75 unit po is atmosphere or ATM. So now this is your final answer for sample problem number 1. Okay, so now let's consider sample problem number 2. So the air inside the tire of an automobile car has a pressure of 1.99 atmosphere at 25 degrees Celsius. When the automobile car ran a few distance, the temperature of its tire increased to 38 degrees Celsius. What is the pressure inside the tire at this condition? Express your answer in millimeters of mercury. Okay, so kung ano yung binigay, again, huwag tayong mag-assume unless stated. So here, dahil sinabi naman na dapat millimeters of mercury, ilalagay natin ang answer natin in millimeters of mercury. So, nung nakaraan, may mga nagtatanong sa akin, Sir, bakit minsan ATM yung nilalagay ng ating unit or minsan bakit liters or ml dun sa mga nauna nating sample problem? Take note, kung ano po yung may iwang unit talaga, yun yung unit for the answer. Pero kung may hinihingi yung mismong problem sa'yo na i-convert mo yung answer mo sa ganitong unit, like for example this one, instead na ATM yung maiiwan sa'yo, dahil gusto ng problem na i-convert mo into millimeters of mercury yung answer, kailangan mong sundin. So, ganun sa math. Kailangan mong sundin yung binibigay sa instruction. Here, sabi niya, i-convert pa natin after natin makuha yung answer natin, we need to convert that sa millimeters of mercury na unit. And kailangan natin siya sundin. Okay, so let's start. Let's begin with our solution. Here, then given. So, ang mga given po sa atin here, the air inside the tire of an automobile car has a pressure of, so meron daw tayong initial pressure of 1.99 atmosphere. Okay? When the automobile car ran a few distance, the temperature of its tire increased. Okay? So, kanina, sa 1.99 atmosphere, yung 1.99 atmosphere na yun ay nasa initial temperature na 25 degrees Celsius. So, T1 is 25 degrees Celsius. And then here, sabi niya, the temperature of its tire increased to 38 degrees Celsius. Ibig sabihin, tumaas yung temperature natin to 38 degrees Celsius from your 25 degrees Celsius. Again, the key term para malaman mo kung ang binigay sa given is final state or here, final temperature, may term na increase or decrease. So here, ibig sabihin, hindi ka mag-increase or magde-decrease kung walang initial condition na binigay sa'yo. Here, ibig sabihin, from 25 degrees Celsius, nag-increase yung temperature mo to 38 degrees Celsius. So, your 38 degrees Celsius is your final temperature. Okay? So, ibig sabihin, mayroon siyang initial condition at yun ay 25 degrees Celsius and bigla siyang tumaas yung temperature. Nagkaroon ka ng 38 degrees Celsius and that 38 degrees Celsius is your final temperature. 38 degrees Celsius. And here, Sabi sa problem, what is the pressure inside the tire at this condition? So, ang hinahanap niya sa atin is yung pressure sa condition na 38 degrees Celsius. So, ibig sabihin, sa final temperature, hinihingi niya sa atin yung, sa final temperature na 38 degrees Celsius, hinihingi niya sa atin yung final pressure natin sa condition na yon. Okay. And again, hindi ka makapag-perform ng operation kung hindi mo i-convert yung temperature into Kelvin. So again, convert natin into Kelvin. So again, your formula for Kelvin is equal to degree C plus 273.15. Okay, here K is equal to degree C value for T1 is 25. So, ito po yan, yung T sub 1, i-convert lang natin yung degree Celsius into Kelvin temperature dahil hindi tayo pwedeng mag-perform or sabihin natin mag-calculate nang hindi kino-convert into Kelvin temperature or Kelvin unit yung ating given unit na nasa degree Celsius. So, here, degree C value is 25 plus 273.15. So, with this formula, mako-convert natin yung degree Celsius natin into Kelvin. So, here, 25 plus 273.15 is equal to 298.15 with the unit Kelvin. So this is your first temperature conversion. Next, let's convert this. Next is your T sub 2. K again is equal to degree C plus 273.15. Then your final temperature is 38 degrees Celsius plus 273.15 mula sa formula ng conversion. So here, 38 plus 273.15. Here we have 311.15 with unit. Ano pong magiging unit natin here? Ang magiging unit is Kelvin. So here we have 311. Okay. Check ko lang ulit sa ating calculator kung tama. Here, meron kang 38 degrees Celsius. Tama naman. 38 plus 273.15. You have 311.15. Okay. So, nasa tamang landas naman po tayo. Okay. Then, what is the pressure inside the tire? Ngayon, na-convert na natin siya. Yung goal natin is kunin yung formula for final pressure. Again, punta ka lang lagi sa main formula. Inuulit-ulit ko yung step para matandaan ninyo yung process. So, P1 over T1 is equal to P2 over T2. And here we have P1 T2 is equal to P2 T1. Again, your goal is to eliminate yung T1. Divide both sides by T1. Cancel to. Now, you're left with formula for P2. So, your formula for P2 is equal to, here we have P1, T2 over T1. Then, distribute lang value. P2 is equal to, your P1 value is 1.99 atmosphere. Okay. Times, your T2 value is, here, instead na degree Celsius na value, papalitan na po natin yan. Erase lang natin. Lagay ko muna yung unit para hindi kayo malito. Ay, sorry, yung value. So, here, yung kaninang 25, siya na ngayon ay 298.15 Kelvin. Kasi kinonvert natin siya into Kelvin. Then, this 38 na yun, kanina, ay, siya na po ay, ito ay, ano na po, 311.15 Kelvin. Okay? So, now, we can now proceed. Again, balik na tayo doon. T sub 2 value is 311.15 Kelvin. And here, divided by T sub 1. Your T sub 1 value is 298.15 Kelvin. Then, pakita yung cancellation again. Cancel this Kelvin unit. And now, you are left with unit atmosphere. So, now, we have your P sub 2. So here we have 1.99 times 311.15 over 298.15. And now meron tayo here 2.076. Okay? Or same po ito sa 2.08 and with the unit atmosphere. Sige, lagyan natin ng box. So, ito na po ang ating final answer. 2.08 atmosphere. Pero may nalilimot ba tayo? Meron po. Kung ito ang final answer natin, tama naman siya. Pero hindi pa siya yung final na final. Again, hinihingi po sa atin sa statement na i-express itong answer na ito into millimeters of mercury na unit. So, we need to convert this atmosphere into millimeters of mercury. So, erase lang natin yung box kasi hindi pa siya yung final answer. Lagay lang tayo ng arrow para hindi kayo malito. So, ito po, i-convert lang natin into millimeters of mercury. So, erase natin to. Kunin natin yung area dito. So, your 2.08 atmosphere, convert po natin. Here we have 2.08 atmosphere. Let's convert this value po sa millimeters of mercury. And take note, sa conversion ng millimeters of mercury, your 1 atmosphere is equal to, so here your 1 atmosphere ay equal po saan? Equal siya sa 760 millimeters of mercury. So here, cancel. Gamit akong ibang kulay para hindi kayo malito. So here, dahil may parehas ng atmosphere, cancel ito. Okay, wag malito dito kasi ito po yung una nyong lesson, tama? Tinuruan ko kayo mag-convert ng pressure unit. Kaya po una natin yung measurable properties bago tayo nag-proceed with calculation. So here, ikino-convert lang natin yung answer nating 2.08 atmosphere into 760 millimeters of hindi to 760. Kino-convert natin yung atmosphere into millimeters of mercury unit. So here, and with that conversion, i-consider natin 1 atmosphere is equal to 760 millimeters of mercury. And ano po magiging answer for that? The answer po, kung i-convert, 2.08 times 760 divided by 1. So here we have 1,580.8. Ang final answer mo po ay 1,580.8 with unit millimeters of mercury. Okay, so now this is your final answer. Again, this is now your final answer. 1,580 millimeters of mercury. Okay, so now let's consider sample problem number 3. Okay, so sample problem number 3 here is the question. If a gas in a closed container is pressurized from 15 atmosphere to 16 atmosphere or ATM, and its original temperature was 25 degrees Celsius, what would the final temperature of gas be? Okay, so here, sulat muna natin solution. Here, meron kang, if a gas in a closed container is pressurized from 15 atm to 16. So, your initial pressure is 15 atmosphere. Pressurized daw siya from 15 to 16. So, your final pressure is 16 atmosphere. And then, and its original temperature was 25 degrees Celsius. So, your T1, or initial temperature, kasi yun ang yung original temperature here, is 25 degrees Celsius. Okay, and its original temperature was 25 degrees Celsius. What would the final temperature of gas be? So here we are looking for T sub 2 or final temperature. Okay, so derive muna natin yung formula for final temperature. So final temperature again, kailangan alam mo yung main formula for Lussac'S Law. Main formula is P1 over T1 is equal to P2 over T2. Then next step is cross multiplication. P1 times T2, then P2 times T1. So magiging P1 T2 is equal to P2 T1. Then after nyan, your goal is to get the formula for T sub 2. So, ito ang ating T sub 2. Erase natin ang pangit na sulat ko. Okay, here we have T sub 2. Then, divide natin both sides by P sub 1. Dahil your goal is T sub 2, ang T sub 2 mo ay next to your P sub 1, so gagamitin natin pan-divide yung P sub 1. Now, you're left with T sub 2 sa isang side. So, your formula here, T sub 2 is equal to, formula po ay P sub 2, T sub 1 over P sub 1 or P1. Pero hindi ka pa pwedeng bigay ng mga values dito dahil hindi mo pa nako-convert itong T sub 1 mo into Kelvin temperature. So, kailangan natin siyang i-convert into Kelvin temperature first. So, Kelvin, okay, wag yan. Nagamit na natin yan. Nagamit tayo ng blue. So, Kelvin is equal to degree C plus 273.15. Okay, so meron tayong given na degree Celsius in 25 degree Celsius plus 273.15. Add lang natin. So, here, 25 plus 273.15 is equal to 298.15 unit Kelvin. Okay? So, ito na ang ating temperature in Kelvin. So, kailangan mo siyang i-erase para di ka malito. Ngayon, na-convert mo na siya dahil ang kailangan mo sa calculation ay Kelvin temp. This is equal to, your 25 degrees Celsius is same as 298.15 Kelvin. So, with this temperature in Kelvin, pwede ka na mag-proceed with our calculation. So, here, T sub 2 is equal to P sub 2. Your P sub 2 is 16 atmosphere. Then, your T sub 1 is 298.15 Kelvin over P sub 1. Your P sub 1 is 15 atmosphere. Okay? Now, pwede mo na siyang i-cancel. Cancel dahil may existence ka ng both ATM. Then, let's solve for this. 16 times 298.15 over 15. Okay. So, the answer for this, T sub 2 is equal to 318.02 unit po natin. Okay, wait. 026 or 318.03 Kelvin. Take note, Kelvin ang unit natin. And sa question na to, hindi naman na sa'yo pinapa-convert pa sa ibang temperature unit yung final answer. So, kung Kelvin yung naiwan, Kelvin ang main unit mo. Pero kapag yung question ay nanghihingi sa'yo or sinasabi sa'yo na i-convert siya sa other temperature unit, for example, degrees Fahrenheit or degrees Fahrenheit, saka mo lang siya i-convert. Pero pag hindi binigay sa given, huwag gawin. Okay? Yun kasi yung kinakamali ng mga students. Pag hindi binibigay yun sa problem, huwag gawin. Unless yun yung mismong rule. For kagaya nito, kailangan mo i-convert muna in Kelvin temperature bago ka makapag-proceed. Ito ay given na rule. Pero sa case ng final answer, kung walang sinabi na i-convert sa other unit, huwag mo gagawin. Okay? So here, dahil wala namang sinabi na i-convert yung final answer sa ibang unit, kung anong unit na maiwan sa'yo, yun na yung final answer. So here, your final answer is 318.03 Kelvin. Okay, so now let's consider last problem for this Gay-Lussac's Law. Okay, so here, a sample of hydrogen gas is placed in a 3-liter closed container under a pressure of 1.21 atmosphere. So, the same gas sample had a pressure of 2.35 atmosphere when the temperature is increased to 35.7 degrees Celsius. What was the initial temperature of gas in degrees Celsius? So here, ito po ay under pa rin ng Gay-Lussac's Law. Again, solution. Marami sa inyo magtatanong, sir, may given po na liters. Maglalagay po ba ako ng volume para sa given? Hindi po. So here, binigyan ka ng 3 liters. Sinabi ba na nagbago yung 3 liters na volume sa problem? Meron bang increase and decrease sa volume? Wala po. Ibig sabihin, kasi medyo tricky kasi yung mga ganitong problem. So, ibig sabihin po nito, yung volume na yan ay constant kasi walang minention sa problem. Mas maganda kung walang minention sa problem na nagbago siya ng volume. So, here, dahil originally meron kang 3-liter closed container and wala kang nakita sa problem na nag-increase or decrease ito, ibig sabihin, this is constant. You have here a constant volume. Medyo matitrik talaga kayo sa problem na ito, pero kung mamasdan mong mabuti, walang pagbabago sa volume. Walang sinabing pagbabago sa volume na yan. Ibig sabihin, you have here a constant volume. And if you have a constant volume, we are dealing with Lussac'S Law. Tama? So, ibig sabihin here, ang ilalagay lang natin sa given is yung under sa Lussac'S Law. Kasi constant naman here yung 3-liter na volume at hindi siya nagbago. So, here, let's write. So, na closed container under a pressure, so your P1 daw po is 1.21 atmosphere. The same sample had a pressure of 2.35 atmosphere. So, ito medyo tricky din siya. Pero, here, same sample pa rin siya, pero yung pressure po ay iba na, 2.35 atmosphere. So, with this, i-consider po natin na ito ay P sub 2. Okay? So, this is 2.35 atmosphere. Okay? Ngayon, medyo malilito ka kasi walang binigay na increase or decrease sa term. Pero, kung i-consider mo, same gas sample pa rin. So, isipin mo para siyang kumuha ng same, sabihin natin, yung gas sample niya is hydrogen pa rin. Then, kumuha siya, for example, ng certain portion doon. And, meron yung pressure na 2.35 atmosphere. So, when the temperature is increased to 35.7 degrees Celsius, what was the initial temperature of the gas in degrees Celsius? Okay, so ngayon, yun yung isosolve natin. So here, meron kang temperature. When the temperature is increased to 35.7, so nagkaroon na ng increase sa temperature. Pero hindi natin alam kung ano yung initial na yon. So nagkaroon ng increase, nag-increase sa 35.7. So this 35.7 degrees Celsius is your T sub 2. Okay? And ang tinatanong sa'yo, what was the initial temperature of the gas in degrees Celsius? Ang hinahanap natin is T sub 1 in degrees Celsius. So, paano po natin yung sasagutan? Again, ulitin ko lang sa inyo, sa mga nalilito, a sample of gas is placed in a 3-liter closed container under a pressure of 1.21 atmosphere. The same gas sample had a pressure of 2.35 atmosphere. When the temperature is increased to 35.7 degrees Celsius, what was the initial temperature of gas in degrees Celsius? So here, walang sinabing pagbabago sa ating 3-liter volume. So this volume is constant throughout this experiment. So constant siya dahil walang sinabing increase or decrease for this 3-liter volume. Ibig sabihin constant siya. And if you have constant volume, we are dealing with Lussac'S Law. Tama? Then here, yung closed container mo na yon na merong sample ng hydrogen gas ay nasa pressure na daw ng 1.21 atmosphere. So ano tong pressure na unang minention? Ito ang initial pressure. Ibig sabihin, may pressure na nung nandun pa lang siya sa tank na yon. Okay? Or sa container na yon. So the same gas sample, ngayon, kung meron kang katulad na gas sample ng hydrogen at nagkaroon daw yon or may pressure yon na 2.35 atmosphere, ito na yung pangalawang pressure mo. Okay? Kasi kung meron kang same sample, ibig sabihin, yung pressure mo kanina na initial pressure ay magbabago na lang yon sa case ng kung may isang parameter or factor doon sa experiment na magpapabago ng pressure. So here, yung same gas sample mo na ngayon ay nagka-pressure na ng 2.35 atmosphere. Sa case kasi ng problem na to, hindi niya binigay na detalyado kung ano yung nangyaring, sabihin natin, kung anong nangyaring process, bakit nag-increase. And okay lang yon sa chemistry. Kailangan mo talaga siya ma-analyze. So here, the same gas sample had a pressure of 2.35. So this second pressure is your P sub 2. Okay? Then, when the temperature is increased to 35.7 degrees Celsius ngayon, kung yung temperature mo daw ay nag-increase sa 35.7 degrees Celsius, may sinabi siyang nag-increase to 35. So, hindi ka mag-increase kung wala kang initial state or initial temp. So, ibig sabihin, this 35.7 degrees Celsius is your final temperature. And here, the question is, what was the initial temperature of gas in degrees Celsius? So, first, kunin muna natin yung ating formula. P1 over T1 is equal to P2 over T2. Then, cross multiplication, P1 T2 is equal to P2 T1. And then, target natin is your T1. So this is your T sub 1. Then divide both sides by P2. Now we are left with T sub 1 sa ating formula. So here we have T sub 1 is equal to P1 T2 over P2. Okay? Then, kailangan mo siyang i-convert. We need to convert this degree Celsius na given into degrees Kelvin. Into Kelvin. Walang degrees Kelvin. So, Kelvin lang. Into Kelvin temp. So, Kelvin is equal to degrees Celsius plus 273.15. So, K is equal to this given. The given is 35 plus 273.15. Okay? So, let's add this. 35 plus 273.15. Now, your answer is 308. K is equal to 308.15 and your unit is Kelvin. Okay? Now, substitute na po natin. So, T1. So, this 35 degrees Celsius, para di ka malito, ilagay mo na yung kinonvert mo into Kelvin na value niyan. So, your 35 degrees Celsius ngayon ay 308.15 Kelvin na. Okay, kinonvert lang natin siya. Huwag malito. Kinonvert lang siya. So, here we have P sub 1. Your value is 1.21 atmosphere. Then, after this, we have T sub 2. Your T sub 2 is 308.15 Kelvin over P sub 2. So, your P sub 2 is 2.35 atmosphere. Okay. So, ang gagawin next is cancel atmosphere, and now we're left with unit Kelvin. Calculate na natin. And this is 1.21 times 308.15 over 2.35. This is equal to 158.664. Okay? Or 66 na lang, 66 Kelvin. Take note, hindi ka pa tapos sa problem. Ang sabi niya, what was the initial temperature of gas in degrees Celsius? So, we need to convert this value into degrees Celsius. So, marami ang magtatanong sa inyo, Sir, bakit pa natin kinonvert sa Kelvin yung given na degree Celsius? Kapag ginamit natin yung diretso, maiiwanan tayo ng unit na degree Celsius. Ganito po yan. Hindi po yun pwedeng gawin. Okay? Hindi siya pwedeng gawin sa pagsasolve ng Lussac'S Law. Kasi, sa mga susunod na problem, mapapansin nyo na magbabago, iba ang answer kapag degree Celsius yung ginamit nyo sa solution at hindi Kelvin na temperature. Kaya, makinig po kayo sa akin, bilang na-master na itong gas law na to, hindi po siya pinapayagan. Nagagamit tayo ng degree Celsius sa solution. Okay? Kelvin po talaga dahil ang lowest attainable temperature ay nasa Kelvin. So, dapat Kelvin ang gagamitin nating standard. And kung degree Celsius pinako-convert niya sa'yo dito sa final answer, hinihingi sa'yo ng problem na i-convert yung answer mo into degree Celsius, saka magpo-proceed with formula. Okay? So, here, to convert this Kelvin into degree Celsius, balik ka lang dun sa formula mo. Take note that your Kelvin is equal to degree C plus 273.15. And kung ita-derive mo yung formula dyan for degree Celsius, ang mangyayari lang ay lipat mo lang sa kabila ito. So, K is equal to minus 273.15. So, may formula ka na for degree C. So, your degree Celsius po ay equal sa Kelvin value. Ang Kelvin value mo ay, sige, rewrite lang natin. Wala na tayong space. So, your Kelvin value is 158.66 minus, erase ko lang ito 273.15. So, equal daw yun sa degree C value. So, try natin. So, 158.66 minus 273.15. Ito po ay equal sa negative 114. So, gamit ako ng black. So, this is equal to negative 114.49 degrees Celsius. So, lagay ko lang dito sa baba para di ka malito. This is your final answer in unit degrees Celsius. Kasi, again, bakit degrees Celsius in unit? Kasi yun po yung hinihingi. Take note ng problem. Stated sa problem na kailangan i-convert yung final answer to degrees Celsius. So, this is your answer.